So hello and welcome in this video on two-dimensional random variable. So in today's video, I will give you a very quick recap or you can say a quick review of two-dimensional random variables. Okay. In fact, in particular, we will discuss about two-dimensional continuous random variable, and with the help of a single problem I will try to cover each and every aspect of our two-dimensional continuous random variable. So this single problem will give you an idea that how we can handle different types of problem related to two-dimensional continuous random variable. In fact, we will particularly address the expectation of two-dimensional continuous random variable. Okay, so let us begin with the problem itself, and here we are given with the joint PDF of two-dimensional continuous random variable. So let us consider that x and y are jointly distributed continuous random variable with the joint PDF. We are also provided with this joint PDF. So this joint PDF is given as fxy, and this is defined as k times xy when this x is lies between 0 to 3 and y lies between 1 to 3, and this is 0 elsewhere. Okay, so means apart from these values of x and y, this function is 0 everywhere. Now we have to find expectation of x and expectation of y, and the joint expectation of xy, and next we have to find out the variance of x, variance of y, and lastly we have to find out the covariance of xy, and also we have to find out the r, which is our correlation coefficient. Okay, so we have to find these many things. That's why this problem will cover every aspect of the two-dimensional continuous random variable, in particular related to the expectation, right? So now let us begin with the solution of this problem. Now if you look at this joint PDF, then here you can see that we are having an unknown involved here, which is k. So first of all we have to determine the value of k. Okay, so our first step is to find out the value of k. What is the k? And to determine this k, we will use the property that when you integrate, in fact double integrate our joint PDF within the limits minus infinity to plus infinity, so it will produce 1. So this is the general property. This property we will going to use here in order to get the value of the unknown involved in our joint PDF. So now because these limits are the general limits, but as far as our problem concerned, this these limits will be 0 to 3 for x and 1 to 3 for y, because it is how we are having this joint PDF, right? So we will use this as double integration. First of all we are putting the limits of x 0 to 3, then the limits for y, which is 1 to 3, and we are putting here this fxy. So since k is a constant, we can take it outside, and we are integrating, in fact double integrating this PDF, and we know that because it is PDF of the random variables x and y, so this integral will always be equal to 1. So now we will integrate first with respect to x. So this will be 1 2 3 because this is the limits for y, and y we will keep as it is, and when you integrate this with respect to x, so this is x square over 2, and here we are having dy. Okay, so we have to integrate this with respect to y, and the limits for x are 0 to 3. So when you evaluate these limits, so this will be k times 1 2 3 y, and this will be coming out as when you put the limits, so this is 9 by 2 minus 0, and we have to integrate with respect to y. Now this will be 9 by 2 minus 0 will be 9 by 2, so this is a constant, so you can and of course this value of this integral is equals to 1. So next what we will do, we will take this 9 by 2 outside because it is a constant, and we have to integrate y with respect to y, and here we will get 9k by 2, and when you are integrating y with respect to y, so this is y square by 2, and the limits are 1 2 3 is equals to 1. So from here we will obtain 9k by 2, and when you evaluate, when you are putting the upper limit here, so this will be 9 by 2 minus 1 by 2 is equals to 1, and this gives us 9 by 2 minus 1 by 2 will be coming out as 4. So this will be 9k by 2 multiplied by 4 is equals to 1, and from here we will obtain 18k is equals to 1, and this further gives us the value of k as 1 by 18. So once we are having this value of k, then our joint PDF is completely known to us, because our fxy is given as kxy, so this will be 1 by 18 xy. Okay, so this is how we obtain our unknown involved in our joint PDF. Now next we have to find out the expectations of x, expectation of y, the joint expectation. So here what we have to do, because we have to find out expectation of x, and for expectation of x and expectation of x square we need fx, okay, which is the marginal, okay, which is the marginal of x. Now next we have to find out the expectation of y, and so next we have to find out expectation of y and expectation of y square, and for this we need fy, which is marginal of y. Okay, so this is marginal of y. Now so it is very much clear that we have to first find out the marginals for both the random variables x and y. Okay, so first of all we will find out fx and fy. So our fx will be the integral of fxy, means the joint PDF with respect to y, and because we are integrating with respect to y, so we have to consider the limits. So because it is the general definition, so I am taking the general limits here, but we have to modify these limits once we are putting our fxy. So our fxy is 1 by 18 xy, and we have to integrate this with respect to y, and the limits for y in this problem is ranging from 1 to 3. So this will give us 1 by 18. Now when you are integrating this with respect to y, so this is y square by 2, and limits are 1 to 3. So this will be 1 by 18 x multiplied by, now when you are evaluating the limits, so this will be 9 by 2 minus 1 by 2. Okay, so this will be 1 by 2. So this is again coming out as 4. So you can say that this is or we can write one more step here. So this is 1 by 18x into we will have 8 by 2, or simply this is coming out as 4. So our marginal of x is coming out as 2 by 9x. Now next we will find out the marginal for y. So because we are finding the marginal of y, so I am just writing the general definition, and here we have to perform this integral with respect to x. So this will be same as 1 by 18. Now the limits for this particular problem are 0 to 3, and our joint PDF, the expression of fxy is 1 by 18 xy, and we have to integrate this with respect to x. So this is coming out as 1 by 18, and when you are integrating, so this will be, because we are performing the integral with respect to x, so you can keep this y outside, and this is coming out x square by 2, and limits are 0 to 3. So this will be 1 by 18 into y into, when you are putting these limits, so this is coming out as 9 by 2, and which gives us the marginal of y as y by 4. So now we are having the marginals for both the random variables x and y. So now we can easily find out expectation of x, expectation of y, expectation of x square, and expectation of y square. Okay, so let us begin with the calculation of expectations. Okay, so here we first find out the expectation of x. So this will be, again I am first writing the general definition, which is minus infinity to infinity x fx dx. Okay, so this will be, when you are putting, now because we are integrating with respect to x, so limits will be for x, and in this particular problem the limits are 0 to 3. Now x and our fx, we obtain this, which is 2 by 9 x. Okay, and this is dx. So this will be 2 by 9 integration x square dx. Okay, so this is coming out as 2 by 9, and when you integrate, so this will be x cube upon 3, and limits are 0 to 3, and this is simply coming out as 2 by 9, and when you are evaluating the limits, so when you are putting x is equals to 3, so you will obtain 9 minus, when you are putting x is equals to 0, so this will be 0. So this is simply 2 by 9 into 9, so this is coming out as 2, which is our expectation of x. Now next we will find out expectation of x square. So again the general definition is minus infinity to plus infinity x square fx dx, and this is again because we are integrating again with respect to x, so we have to consider the limits for x which are 0 to 3, as you can see here in the definition of the joint PDF which we give in the beginning. So you can see that the limits for x are ranging from 0 to 3, so we are putting the limits as 0 to 3. Okay, so this is 0 to 3, and again we can take this because fx is 2 by 9x, so you can take this 2 by 9 because it is a constant, so you can take this outside from this integral sign. So you will have x cube dx, and this x cube is coming out from the product of x square with fx, which is 2 by 9x, right? So 2 by 9 is outside. The expression of this fx is 2 by 9x. Okay, so this x and x square will become x cube. So when you are integrating, this is x to the power 4 over 4, and the limits are 0 to 3. So this is coming out as 2 by 9, and when you are putting the limits, so this is coming out as 81 by 4. So this expectation of x square is coming out as 9 by 2. Now it is very much clear that expectation of x is also same as the mean of x. So this is the mean of x. Now if we have to find out the variance of x, so this will be expectation of x square minus expectation of x whole square. So we are putting here the values of expectation of x and expectation of x square. So this is expectation of x square is 9 by 2 minus the square of the expectation of x. So this is the square of 2, and here we will have 9 by 2 minus 4. So this is coming out as 1 by 2. Okay, so this is our variance of x. Now next we will find out expectation of y and y square. So expectation of y will be minus infinity to infinity, which is our general definition y, and we are multiplying this by the marginal of y. So this is our general definition. Now once you are putting the values, again here we have to consider the, because we are performing the integral with respect to y, so we have to consider the limits of y, and the limits for y are 1 to 3. Now this and fy we just obtained as y by 4. Okay, this fy is we obtain as y by 4. So when you are multiplying this y with y by 4, so 1 by 4 is constant, you can take it outside, and here we are having y square dy. So this is 1 by 4, and here we are having y cube by 3, which is the integral of y square, and the limits are 1 to 3. So this is coming out as 1 by 4, and the limits, when you are putting the limits, so this is 27 by 3 minus, because when you are putting the upper limit 3 here, so this will be cube of 3. So this is 27 minus, when you are putting y is equals to 1, which is the lower limit. Okay, this is our lower limit, so 1 by 3. Now 27 by 3 minus 1 by 3 is coming out as 1 by 4, which we are having here, and this 27 by 3 minus 1 by 3 will be 26 by 3. So this expectation of y is now if you cancel out this by 2, so sorry, this is 13 and here we are having 2, so this is 13 over 6. So this is our expectation of y. Now next we will have expectation of y square. Okay, now this expectation of y square is again minus infinity to plus infinity. Now because we are finding the expectation of y square, so we have to take the product of y square with fy. Okay, so this is the definition. Now again our fy is y by 4, so again we are taking this 1 by 4 outside, and y square into y is coming out as y cube, and limits for y are 1 to 3 dy. So this is 1 by 4, and here we are having y by y to the power 4 over 4, which is the integral of y cube. Now when you are putting the limits, so this is coming out 1 by 4 multiplied by, when you are putting the upper limit which is 3, so when you are putting here, so 3 to the power 4 is 81 by 4 minus, we are having 1 by 4. Okay, so this will be 1 by 4 and this is coming out as 20. Okay, 81 by 4 minus 1 by 4 is 20. So our expectation of y square is 5. Now next we can find out the variance of y. Okay, so variance of y will be expectation of y square minus expectation of y whole square. Okay, so this will be expectation of y square is 5 minus 13 upon 6, which is our expectation of y whole square. So this is 5 minus, we are having 169 over 36. Okay, so this is coming out as when you are taking the LCM as 36. So this is 180 minus 169 divided by 36. So this will be coming out equals to 11 over 36. So this is our variance of y. Okay, now next we will find out the joint expectation. Okay, the joint expectation means expectation of xy. So here we have to use our joint PDF itself. Now this is the double integral, and again I am writing first the general definition. So this will be minus infinity to plus infinity xy fxy dx dy. Now our fxy is 1, it is kxy, initially it is given as kxy. Now first as we obtain initially the value of k, which is 1 by 18. So our fxy is 1 by 18 xy, so you can take this 1 by 18 outside, double integral. Now this xy, and we are multiplying xy, so this will be x square y square. Okay, dx dy. Now the limits for x are 0 to 3 and limits for y are 1 to 3. So this will be 1 by 18 and this is 1 to 3, and because we are integrating this function with respect to x first, so we will keep y square as it is, and the integral of x square is x cube by 3, and the limits are 0 to 3. So this will be 1 by 18 and 1 to 3 are the limits for y square, and of course here we have to put dy, and when you are putting the limits, so this will be 27 upon 3, so that is 9. So this will be 9 by 18 y square dy. Okay, so next when we integrate, or 9 by 18, you can write this 9 by 18 as 1 by 2. Okay, so this will be 1 by 2, and when you integrate this y square, so this is again coming out as y cube by 3, and the limits are 1 to 3. So this is 1 by 2, and this is 9 minus 1 by 3. Okay, so this will be 1 by 2 multiplied by 26 by 3, or you can say that expectation of xy is coming out as 13 by 3. Okay, so this is how we can obtain different types of expectation, means expectation of x square, y square, and the joint expectation. Now we can use these values, and we first obtain the covariance of xy. Okay, so covariance of xy, the formula of the same is expectation of xy, means the joint expectation, minus the product of their individual expectation. Okay, so this is 13 over 3 minus the expectation of x we already obtained as 2, and the expectation of y is 13 over 6. So this will be 13 over 3 minus 13 over 3. So this shows that covariance of xy is 0. Now since this covariance of xy is 0, so our correlation coefficient r, which is defined as covariance of xy divided by sigma x sigma y, here this sigma x is the standard deviation of x and sigma y is the standard deviation of y. Now because we are having this covariance as 0, so this r will be coming out as 0. Okay, so this is how we obtain different types of expectation and the covariance as well as the correlation coefficient. So before we end this video, let's have a quick understanding of the steps involved in this problem. So here you can see that we are initially given with the joint PDF, and this joint PDF involved a constant here. Okay, so here we are having a constant. This constant is involved here. So we use the property of joint PDF, means when we are integrating this joint PDF or double integral this joint PDF, so this should be 1. So this is the property. Now because our joint PDF defined over this region, okay, over this region, so the limits will be 0 to 3 for x and 1 to 3 for y. So that is what we are doing here, and after performing this integral we obtain the value of the constant. So this is the first part. It is very important that we have a clear information of our joint PDF. Now next we find the expectations of x, y, x square, y square. So we have to find out the marginals. Okay, the marginal of x and marginal of y. So we know that in order to obtain the marginals, we have to integrate our joint PDF with respect to y. Now because we are performing the integral with respect to y, so we have to consider the limits for y, which are given as 1 to 3, and our fxy is defined as xy over 18. So that is why we are having this xy, and since 1 by 18 is constant, so we are taking this outside. So after performing this integral, we obtained the marginal of x as 2 by 9x. Okay, now next in order to obtain fy, which is the marginal of y, we have to integrate our joint PDF with respect to x. Now the limits for x are 0 to 3. This is the general definition. Don't get confused with this minus infinity to plus infinity. We have to always consider the limits which are which are obtained from the domain of fxy, means the domain over which our fxy is defined. So when you are performing this integral, you obtain this fy as y by 4. So this will help us to determine the expectation. So expectation of x is x fx. This fx is the marginal of x, which we obtain as 2 by 9x. Again we are integrating with respect to x, so limits are 0 to 3, and this integral provide us the value of the expectation of x, which is 2, and similarly we obtain our expectation of x square, which is coming out as 9 by 2, and then we use these expectation to obtain the variance. So this is coming out as 1 by 2. Okay, so this is coming out 1 by 2. Now in the same manner we obtain the expectation of y. Now in order to obtain this expectation of y and y square, we have to use the marginal of fy, which is y by 4, and again because we are performing the integral with respect to y, so we have to consider the limits for y, which are 1 to 3, and this gives the expectation of y as 13 by 6, and similarly we will obtain the expectation of y square, which is integral of y square fy within the limits minus infinity to infinity. This is the definition. Now because our limits for y are 1 to 3, so that is why we are having here the limits as 1 to 3, and y square multiplied by fy will give us y cube, and we are taking this 1 by 4 outside. So after performing this integral, we obtained the expectation of y square as 5. Now we obtained the variance of y using these expectation of y and y square. So the variance of y is coming out as 11 by 36. Now in order to obtain the joint expectation, we have to integrate the product of xy with fxy within the limits minus infinity to plus infinity for both the variables, and this fxy is 1 by 18xy. So this xy and this xy, when you are multiplying, so we obtain x square y square, and after performing this integral we obtain this as 13 by 3. Now the formula of the covariance is expectation of xy minus expectation of x expectation of y. So this is coming out 0, and due to this covariance is 0, we have r is also 0. So this is how we solved a problem on expectation for the two-dimensional continuous random variable, and of course if this covariance is non-zero, then our r will be non-zero, and always remember that the range for r is minus 1 to 1. Okay, so this is how we handle the problems on two-dimensional continuous random variable and the expectation of the two-dimensional continuous random variable.